Hi children, how are you? I hope you all are fine and taking prevention for this COVID-19. Stay home, stay safe. I am also taking prevention for this COVID-19. Let's today start the next phase of the polynomial. The next phase of the polynomial is the zeros of a polynomial and zero of a polynomial. Very important part which is continuing for the 10th class again. So please try to understand what is the zeros of a polynomial and a zero of a polynomial. Both are these two are sounding same, but they are different. Zeros and zero, they are different. Let's go for the explanation. Consider, I wrote here, see, consider a polynomial px. Why px? Polynomial in x. My variable is x here. So I wrote polynomial in x. That is equal to x square plus 5x plus 4. Very clearly this expression is having the degree 2 and degree 1. So highest degree to be considered. So it is a degree 2 polynomial. Degree 2 polynomials are otherwise called as quadratic polynomials. So it is an expression of quadratic polynomial or degree 2 polynomial. Then you see, now what I want to show you. What is the value of this polynomial at different values of x? Different values of this variable. What is the value of the polynomial we are going to get? So let's x equal to 1, minus 1 and 4. Three values I took and I am putting these values in place of x and getting the polynomial value. You understood? So now you see, before starting that, I want to say you degree 2 polynomial always give you two solutions, two answers. That is, when the polynomial is in this format, ax square plus bx plus c, then definitely there are two zeros are possible. Don't say roots. Two zeros are possible. That is alpha, beta. So only two solutions are there, on which one solution is given here. By putting this one, we are getting the another solution. See now how I am doing. So px, what is my px? My px is equal to x square plus 5x plus 4. Then what I am going to do? I am putting x equal to 1. So polynomial in 1 is equal to 1 square plus 5 into 1 plus 4. That is equal to 1 plus 5 plus 4. That is equal to 10. So when I am putting 1 here, you see I got the value 10. Two values I got. One is alpha and there is beta. Two solutions I got. By putting one solution, I got the another solution. Next, put the p equal to minus 1. P is minus 1 here. So now minus 1 square, that is plus 5 into minus 1 plus 4. What is coming? 1 plus into minus, that is minus, then 5, then plus 4, that is equal to 0. Why? 4 plus 1, 5, 5 minus 5, 0. So when I put minus 1, I got 0. So minus 1 is one solution and 0 is the another solution. Here 1 is one solution and 10 is the another solution. Similarly, put 4. Then what you are getting? P of 4, that is equal to 4 square plus 5 into 4 plus 4. That is equal to 16 plus 20 plus 4. That is equal to 36. This is coming 40. So now when I put 4, I got 40 as my next solution. Clear? So these are the different solutions I got. 1, 10, minus 1, 0, 4, 40. This pair is called as the zeros of a polynomial. That means these are the solutions for this polynomial. Solutions means answers of the polynomial. We are getting two answers for it, alpha and beta. Here the alpha is 1 and beta is 10. Here alpha is minus 1 and beta is 0. Then here alpha is 4, beta is 40. So like that we can try many values for x and get many solutions. So these solutions are called as the zeros of a polynomial. Try to understand zeros of a polynomial. It is totally different from this zero of a polynomial. In this expression I am explaining what is zero of a polynomial. Very important, try to understand. See now, when I put 1, I got 10. When I put minus 1, I got 0. When I put 4, I got 40. But on which value this polynomial becomes 0? Very clear, minus 1. In minus 1 value, the polynomial becomes 0. The value of the polynomial becomes 0 at the value of minus 1. So on which value the polynomial is coming 0? The polynomial value is coming 0. That value which you are putting, that value is called as the 0 of a polynomial. I hope you understood the difference between the zeros and 0. 0 on which value you are putting, and it is the value, total value of the polynomial is coming 0. That value is called as the 0 of a polynomial. And so the solutions 1, 10, minus 1, 0, 4, 40. These are called as the zeros of a polynomial. So on which, in general, we can say on which value the polynomial value becomes 0, that is called as the 0 of a polynomial. And the solutions of a polynomial, how many solutions? 2 solutions. So the 2 solutions are called as the zeros of a polynomial. Mainly they are taking the solutions as alpha and beta. I hope you understood this part. There are some book questions are there. Let me find out. That is page number 33. What I am saying, please see. Page number 33. Page number 33. Do these sums are there. Please do it. That is on the zeros of the polynomial. And also the page number 34. Example 1 and 2 and 3 are the same sums, by where you have to calculate the zeros of the polynomial and the 0 of the polynomial. Similarly, there is some exercise sums for you, exercise 2.2, and it will be discussed with you later. And now come to the next part of the polynomial. The next part of the polynomial is called as the dividing a polynomial. The dividing a polynomial. The next part is called as the dividing a polynomial. What is that? Dividing a polynomial. So we are right now going for the division of the polynomials. So let's see how the divisions will go on. Very important, please try to understand. It is continuing for the 10th class again. So the heading is dividing a polynomial. The heading is dividing dividing a polynomial. See now, polynomial. So now you see, when I am just going for this heading, dividing a polynomial, I am giving some expressions to you. Let's go for the expressions x by x, 2x plus 1 by x. Then I am writing here 2x square plus 2x plus 1 by x plus 1. Then I am writing here 2x cube plus 2x square plus 2x plus 1 by x square plus x plus 1. See now. See these different types of expressions I am giving to you. These are all the divisions. Here it is a monomial having single term. So it is a monomial. Monomial with a monomial division. It is a binomial with a monomial division. It is a trinomial or multinomial or polynomial with a binomial division expression. And here it is C. It is a multinomial with a multinomial. So this type of expressions will be available for you for the forthcoming divisions. Let's see how to divide and what is the trick involved in the division. So let's go for a book sum. I am doing a very simple sum for you first. The book sum is, it is taken, the book sum is 3x square plus x minus 1. We took 3x square plus x minus 1 divided by x plus 1 divided by x plus 1. Clear? Okay. So now you see very clearly, this is a multinomial divided with a binomial. This is a multinomial divided with a binomial. Multinomial divided with a binomial. So when I am going to divide, first of all, try to remember this is my dividend. In 4th class you did it. This is my dividend. This is my divisor. So dividend, divisor. So when you are writing that, how to write, I am saying, see, 3x square plus x minus 1. Write very, put a space between them. Put a space between them by which the dividend will look very clear to you. And many students will write it very clumsily. That means what the next step will go on, you will be confused. So better write it giving some space inside them. So now I am going to divide it with the x plus 1. I said you now a trick is involved. So what is the trick? See now the trick is what is the first term of this one? The first term is 3x square for dividend. The first term for divisor is x. So first term by first term, that is the trick. First term by first term, that is the trick involved in it. So what is the first term? Here it is, the first term is 3x square. What is the first term of the divisor? X. Now go for division. With sign. What is the sign? Nothing is here, plus. So it is plus 3x square by plus 3x. Plus 3x square by plus x. I'm sorry, it is plus x. That is equal to, see now, plus divided by plus, it is plus, and actually for 1 here, cut it. So it is 1, so it is 3 now. 3x. So what is coming? 3x. I am writing the quotient here. Due to no space is here available. I am writing the quotient by taking the quotient out. See now what is coming? So it is plus 3x. Right here plus 3x. After that you have to multiply this with the both. That means plus into plus. Right here plus 3x into x. That is 3x square. Now you see it is plus into plus. It is plus. And write 3x into 1, 3x. But when you are writing the second term, always please multiply and write in rough plus 3x. Plus into plus, 3a into x into 1, 3x. Because you have to know whether it is coming like terms or not. Sometimes it will not come. So you have to first of all know that what is my term coming and put it in the right column. That is very, very important. So now you see, we are after this term, we are going to subtract the 2. We are going to subtract the 2. So subtraction means plus into minus. Minus means the change of sign. You have to do the sign change. Plus is there, so it will be minus, and plus is there, it will be minus. By looking this sign, change sign, we are going to solve. It is plus 3x square, minus 3x square cancelled. Then it is 1x. Then minus 3 plus 1, it is minus 2x. Then 1 is getting down. That is minus 1. Clear? Now we got the second step. What is the first term in the second step? That is minus 2x. What is the first term here? The plus x. It is minus 2x by plus x. What is coming? Minus by plus, it is minus, x is cancelled, it is 2. It is coming minus 2. Now multiply minus into plus, it is minus x into 2, 2x. Then it is minus into plus, write it in rough, don't write it here. Minus 2 runs are 2. What is coming? Minus 2. I can put it now. Minus 2. Then change the sign because it is subtracted. So minus 2x and plus 2x cancelled. It is coming plus 1 now. This plus 1 is the remainder, and this much is called as the quotient, and this is called as the divisor. This is the divisor, and this is called as the dividend. So after doing this sum, you have to know how my sum is right or wrong. While a sum is right or wrong, how will you know? That is called as the check. Check your answer. Check the answer. The check is in the 4th and 5th class you did it. That is dividend is equal to divisor into quotient plus remainder. That one is the check for you. Dividend is equal to quotient into divisor plus remainder. Clear? Or you can say D into Q. Divisor into quotient also you can say. Divisor into quotient plus remainder. Divisor. Okay. So dividend equal divisor into quotient plus remainder. What is the divisor here? X plus 1 into 3x minus 2 plus 1. If it is giving your dividend, then your total sum is absolutely right. So that is the check for your answer. Before that, I want to say you something. See, the trick is I call first term by first term. So see now, dividend first term is changing. Here it is plus 3x square. When you are coming to second step, it became minus 2x. Like that, the dividend first term is changing. So dividend first term is changing. See now, plus 3x square minus 2x. But throughout the division, the divisor first term will never change. That is, look, x, it will continue like that. So divisor first term will never change. The dividend first term will go on changing. Divide it according to the symbol, put it and multiply this number with the both and write it. and go for the second step. Also divide the first term by first term, and what is the number you are getting, put it, again multiply with the 2 and change the sign. Change the sign is very, very important. Try to remember, you have to change the sign nicely because it is subtracted, and get the remainder. And after that you go for your check. Check is the dividend is equal to divisor into quotient plus remainder. This is the funda behind the division of a polynomial. Very easy, you can do it nicely. But sometimes you will be in trouble. Just the next sum I am doing for you is a little bit different from this sum. So for that reason I said you, when you are multiplying the second term, please write it in the rough. Why? Because sometimes it will not come as the like columns. So it may create a problem for you. Clear? So next sum I am doing for you. Try to understand the difficulties when you are doing the sum. You can go through it nicely. See now, I am doing the second sum for you. What is the second sum? That is, I am taking from your textbook the second sum. The textbook sum is a little bit, it is a degree 4 equation. I think it is there in your book. Yes, that is called as 2x4. See now, 2x to the power 4 minus 4x cube minus 3x minus 1, see, divided by x minus 1. See now, here only one thing you see, here only the degree is 4. It is a biquadratic polynomial. Biquadratic, that means biquadratic polynomial is divided with a binomial. Okay, let's divide it. First of all, when you are going to start the division, the most important point to remember, see the dividend powers are arranged in order or not. It must be in the descending order. It must be in descending order. So here it is 4, here it is 3. There is no 2. See, there is no 2. Degree 2 is absent here. So when you are writing, if you will write the degree 2 by introducing the degree 2 here, then it will not create a problem in the further division. So look this question, how I am going to write it. See, my 2x4 is there, I wrote it. My minus 4x cube is there, I wrote it. But after that I must write the degree 2. Here degree 4 is over, degree 3 is over. So degree, what is that? Degree 2 is absent. What I am writing, see, 0 into x square. So 0 into x square is 0. So it has no value now. But you have to write like this to avoid the difficulties what is coming in the next step. So now it is degree 1 is there, minus 3x to the power 1 and minus 1 divided by, this is the proper dividend now for you. It arranged. What is missed? The degree 2 is missed here. I wrote the degree 2 by putting 0 into x square. Understood? Then you go for your division. What is your division? That is x minus 1. Clear? Now the same thing, the trick. Here is the first term, 2x4, first term, x. Take it with the sign. The trick I am saying to you. What is the trick? Now plus 2x4, it is plus now. Nothing is there. Plus 2x4 by plus x. What is that? Plus 2x4, x to the power 4 by plus x. What is coming? Plus by plus, plus x to the power 1 cut with 3. That is 2x3. 2x to the power 3. I can write my quotient here because no place is available. So I can write it. I am just writing the question. I hope you understood the question what I wrote. Now I am writing my quotient. What is my quotient came? Plus 2x cube. Okay, here it is came plus 2x cube. Put it here and multiply. Plus into plus, plus 2x cube into x, 2x4. How I am saying the multiplications I am doing, like that you do. It will never create any problem for you. Plus into plus, again I am showing plus into plus, plus 2x cube into x, 2x4. Then what you should write it in rough. Plus into minus, minus 2x cube into 1, 2x cube. Is there 2x cube after 2x4? Yes. Then you can maintain this one here. So it is minus 2x cube. Now it is over. Change the sign. I said you because it is subtracted. So plus is minus, minus is plus. Then it is plus 2x4, minus 2x4 cancel. Then what you got? You got minus 4 plus 2. These two are like terms. Very easy now. minus 4 plus 2. Don't go for minus 2. Minus 4 plus 2. Changing sign. Changing sign you have to take. Minus 4 plus 2. It is minus 2x cube. Then again write plus 0 into x square. It will come down as usual. It will come down as usual. It will come down as usual. Minus 3 x to the power 1 minus 1. Understood? Clear? Now you see what is the first term now? I said only the dividend first term will go to change. The divisor first term will remain same. So minus 2x cube, it is minus 2x cube by plus x. Plus x. Now it is minus x to the power 1 cancel here 2. Now it is 2x square. What is coming? Minus 2x square. Again multiply this with the both. Minus into plus minus 2x square into x, 2x cube, then minus into minus, write it in rough, 2x square into 1, 2x square. Is there any 2x square? Yes, it will go to the x square column. So now it is plus 2x square. Then what we will do? Change the sign and subtract. Then plus 2x cube, minus 2x cube cancelled, then minus 2x square, minus 2x square. Minus 3x will come down, minus 1 will come down, minus 3x, minus 1. See now, in our whole question, x square is 0, but here x square came, minus 2x square. For that reason I said you have to maintain what is not there in the question, you have to maintain that by putting a 0 into, okay. So now it is the first term, minus 2x square, right here, minus 2x square, by, here it is plus x. Plus x. Now it is coming minus x to the power 1, it is 1, 2x. So it is minus 2x. Now multiply minus into plus, it is minus 2x into x, it is a 2x square. Now it is minus into minus plus, write in rough, 2x into 1, 2x. Can I put? Yes, 2x column is there. So plus 2x. Clear? Now change the sign, plus, and it became minus. Then both are cancelled. Minus 2x square plus 2x square. Minus 3 minus 2. Minus 5x. Minus 5x. 1 will come down. That is minus 1. Then what is the first step? Minus 5x. What is the first step? Minus 5x. First is first term. It is term. First term. Minus 5x plus x. By plus x. What is coming? Minus x is cancelled. That is minus 5. Put minus 5 here. Minus into plus. It is minus 5x. Then minus into minus. It is plus 5. Clear? Now change the sign. Plus is minus. Cancelled. Minus 1 minus 5. That is what is coming? Minus 6. Minus 6 as the remainder. And this much is your called as the quotient. And this is called as your divisor now, divisor, and this is your dividend, dividend. When you will go for the check, go for the check. What is the check? Check is dividend is equal to divisor into quotient plus remainder. So these two you have to multiply, this and add minus 6, you have to get the required dividend. If it is coming, you are absolutely right. So this is the fonda behind the division of the polynomials. I hope you understood it. It is a little bit different from the first sum. What is absent here? Here is the degree 2 was absent. So what I did, I put 0 into x square. I hope you understood this. Thank you very much. The next part is called as the Reminder Theorem. It is a very important theorem. Please try to understand it with me nicely. So what is about Reminder Theorem? Reminder Theorem is, here it is written, see what I am saying to you. Let polynomial x, my variable is x. Let my polynomial x be any polynomial of degree. What is my degree of the polynomial? Is greater than or equal to 1. That means it is more than 1, the degree. Degree means the power. It is more than 1 or it is equal to 1. That means it is a linear polynomial or it is a quadratic polynomial, a cubic polynomial, like that. And let a be any real number. try to understand this part. Let A be any real number. If you are thinking about a real number, then what is happening? If polynomial x, now you are dividing this polynomial x. What is this polynomial? It is the polynomial of degree greater than 1, greater than or equal to 1. It may be a linear polynomial, may be quadratic polynomial, may be cubic polynomial, may be biquadratic polynomial. And if A is any real number, you are thinking about a real number, 1, 2, 3, 4, 5 like that. If polynomial x is divided by the linear polynomial x minus a, that means you are going to divide this polynomial of degree more than 1 or equal to 1 with another polynomial, that is a linear polynomial, that is x minus a. See, it is clearly written x minus a. That means it is having the degree 1. So it is a linear polynomial. Then the remainder will be the real number you will think. The remainder will be the real number. That real number you take, that real number is coming as the, what is that? It will be the remainder. So again I am saying to you, if a polynomial you are taking of degree greater than 1 or equal to 1, the degree equal to 1, it is called as a linear polynomial. Greater than 1, it is called as a quadratic polynomial or biquadratic polynomial or cubic polynomial. And if a is any real number, then what is happening? If you are dividing this polynomial px with another polynomial, linear polynomial x minus a, let it be gx. If you cannot understand, let take it as gx. Okay, so when px is divided by gx, the polynomial which is having the degree greater than 1 or equal to 1 divided by another linear polynomial gx, then the remainder will be the real number in that polynomial. Clear? It will give you a remainder which is a real number. Let it be a or polynomial in a. Clear? Now I wrote my next part. I think this part is understandable to you. Now you see, we know that by division algorithm. What is the division algorithm? Class 5th study. What is that? Dividend is equal to divisor into quotient plus remainder. So my polynomial px is the dividend here. See, this polynomial is going to be divided by another polynomial that is called gx. So now my dividend is px. Now this px is going to divide with what? Gx. So my divisor is gx. So dividend is equal to divisor. I got a quotient for it, that is, let it be qx, and the remainder let it be rx. I hope you understood. So what is my gx here now? My gx is x minus a. It is a linear polynomial. I said you know. It is a linear polynomial. So it is x minus a. So x minus a into qx plus rx. Then what I wrote in place of gx? In place of gx, I put x minus a because it is given here x minus a. Clear? So now since x minus a is degree is 1. Why? It is a linear polynomial. Said it is a linear polynomial. So what is the degree of the x minus a? X minus a degree is 1. So it is a linear polynomial. Since the degree of x minus a is 1 and the degree of the remainder, what the remainder degree, definitely you have to understand this line. The remainder of the remainder degree, the polynomial which is coming under remainder, the degree of that polynomial must be less than the degree of the x minus a, that means gx. Rx polynomial, Rx the remainder, there will be some polynomial it will come. So that degree must be less than the divisor polynomial degree. What is the divisor polynomial degree? 1. So Rx here is definitely less than the degree of x minus a. What is the x minus a degree? 1. So my remainder is coming less than the degree 1. So definitely the degree of the Rx must be equal to 0. If it is less than 1, then what is the degree of the polynomial? That will be 0. So if it is a 0, then Rx is called as a constant. It is a pure number. If the remainder is a pure number, then the degree is 0. Suppose I am just explaining here. You see px, the polynomial px. Understood? Now px is divided with what? Not gx. What is gx? You took here gx as x minus a. What is it? It is a linear polynomial. Now what you are getting? You are getting a qx. Then what you are getting? You are getting a rx. this Rx, what he is saying, this if it is a linear polynomial, its degree is 1 here, then the Rx degree, suppose Rx is coming 5. So 5 is what? 5 is a number, 5 is a constant, 5 is a number. But of which degree? Of 0 degree, because I cannot do x to the power 0 here. But here it is x to the power 1. So the remainder degree must be less than the degree of the divisor. Divisor degree is 1. Remainder degree is 0. If the remainder degree is 0, then definitely we should not write it, because x to the power 0 is 1. So we should not write. What you are getting? You are getting a perfect number. That is, it is written here, Rx is equal to a constant. Let it be k. Understood? So what can I write? Px. So what I got in the place of px, what I wrote? Gx. What I wrote? X minus a. So what my x is coming? A. A is a real number. So x is coming a now. So a minus a into qx plus constant. Rx is coming a constant now. Clear? So now it is total became 0. 0 plus k equal to k. That means the polynomial is coming the value of the remainder. What is the remainder? That value is called the dividend here. Understood now? So what again I am saying to you, please see, time is there. Let px be any polynomial of degree greater than or equal to 1. So polynomial x, px must be a linear polynomial, otherwise a quadratic polynomial, otherwise a cubic polynomial. Now let's think about a real number, that is a. If this px is going to divide with another linear polynomial, try to understand this line, linear polynomial. So what is your gx or your divisor? Your divisor is a linear polynomial to the power 1. Clear? When it is divided with this, it is giving you the quotient as well as the remainder. Then the remainder is the polynomial in a. That means this a real number must be the remainder here. Clear? So now we know that by division algorithm, what I put p of x equal to divisor into quotient plus remainder. Gx is given here x minus a. I put x minus a into qx plus rx. Then you see, since the degree of the linear polynomial is 1 and the degree of the rx will be definitely less than 1. It is less than the degree of the x minus a. That means it is 0. So Rx degree is 0. Rx degree, try to understand, again I am saying Rx degree, remainder of polynomial degree, that is 0. That means Rx is a constant. If constants are always called 0 polynomial, that means the degree of the polynomial is 0. 5 can be called as 5 into x to the power 0. So it is purely a number. It is purely a number or a constant. So we can write px equal to, what is the polynomial we think about? A real number a. So put the x value a minus a into qx, this is 0, 0 into qx total 0, 0 plus remainder is a constant now, 0 plus constant equal to k. I hope you understood. But the thing is that nobody asked you this one. Nobody asked you this one to do. Everybody will ask you this definition to remember. So this is called as the very, very important part. Clear? So you have to remember the remainder theorem definition. What is that? If the let px be any polynomial of degree greater than or equal to 1 and let a be any polynomial, and if this polynomial is divided with another linear polynomial x minus a, then the remainder will be the real number. That means a constant. That means a 0 polynomial. I hope you understood it. Now regarding this, let's try to do some sums available in your book. Okay. So how they will do? Using reminder theorem, you solve. Okay, that type of sums will come in your question. Let's go to solve these questions. Okay. Now you see, I am doing for you some sums by which you can understand it again easily. So the first sum for you is in your book. It is there. The first sum for you, find the remainder. He is asking page number 41. I am doing page number 41. Open the textbook, and when you are coming to the video class, please watch with your textbook, rough note and pen definitely, by which when I am saying the page number and the sums, you can easily understand that. So now the question is, see now, the question for you is find the remainder. Find the remainder. Find the remainder. He is asking you the remainder. But find the remainder when x cube plus 1. X cube plus 1 is divided with x plus 1. See now. Why I not drop this? I want to explain you with the sum. See now how I am doing. See now, he is asking what? Remainder. So then what should be the remainder? The remainder we don't know. But we know the polynomial that is of degree greater than or equal to 1. See, here the polynomial is greater than or equal to 1 degree. That is, here it is 3. It is a cubic polynomial. And it is divided with the polynomial, linear polynomial. Look, linear polynomial. Yes, it is divided with a linear polynomial. That is x to the power 1. Then what to do? So this polynomial is going to divide with the gx. Px is divided with the gx. I am writing here px, by which answer I am writing. See, let write that this px is equal to, polynomial in x is equal to x cube plus 1. Then what is said? Gx, another polynomial, that is a linear polynomial. What is that? X plus 1. So now you see this gx is x plus 1. Let it be equal to 0. Let it be equal to 0. Then what will happen? X plus 1 is equal to 0. Because gx is x plus 1. So x plus 1 equal to 0. What the value we got? X equal to minus 1. Now you put this x value here. Because this is the real number. This is the real number to get the remainder. This is the real number to get the remainder. So now you see, I am doing here. This sum is continuing here now. You see, and px, I am putting p of minus 1. Then what is coming? Minus 1 cube. X is minus 1. So minus 1 cube plus 1. What is coming? Minus 1 plus 1. What is coming? 0. So the polynomial with 1 is coming 0. So by the remainder theorem, we know that when it is divided, this one is divided with this one, the remainder it is going to give you the 0. It is going to give you the remainder 0. You can check it by last video I said you division. You can division method. You can check the division method whether the remainder is coming 0 or not. I hope you understood this sum. Very easy sums. Then another one sum I am doing for you. See, he is doing page number 41. Another question I am solving for you. Look at it. What is saying? This type of questions will come to you. Check whether, question is, check same page number 41. See now, check whether, what is saying? X minus 2 is a factor of, x minus 2 is a factor of another polynomial is given to you. Factor of the given polynomial, x cube minus 2x square minus 5x, x cube minus 2x square minus 5x, I think it is plus 4. Yes, plus 4. Okay. So now he asked you, you have to check whether this polynomial is a factor of this polynomial. So this polynomial is your px now. So what is px? It is greater degree. What is the degree of the px? Greater than or equal to 1. So it is greater than 1 now because it is a degree 3 polynomial. So it is greater than 1. Now what the polynomial you are going to divide? It is a linear polynomial. See, it is a linear polynomial having, clear? So now what to do? You have to write, let your px be. What is your px? Now px is x cube minus 2x square minus 5x plus 4. Clear? Now what is your gx? Gx is equal to x minus 2. Then what you have to do? Let this gx be equal to 0. So let therefore x minus 2, that let it be equal to 0. X minus 2 equal to 0. That implies x is equal to 2. Clear? You got the value of x now. This value of x you can put it here. Polynomial in x. That is 2 cube. What is that? Let's put it here. Go for the next sum. I am doing here. So p of 2. What is p of 2 now? 2 cube. It is 8 minus 2 square. 4. 4 into 2. 8 minus 8. And then minus 5 into 2. 10. Minus 10. Then plus 4. What is coming? 8 cancelled. Now it is coming minus 6. What is saying? It is coming minus 6. If after putting the value, you see, what should it come? It should come 0. If it is coming 0, then x minus 2 is a factor of this polynomial. But here it is what coming? Minus 6. Therefore, you have to write here, therefore, x minus 2 is not a factor, is not a factor of the polynomial, this one. Factor of x cube minus 2x square minus 5x plus 4. Understood? Clear? You got it what I said? After getting the value of x, if when you are putting the value of x here, if you are getting here 0, then this is the factor of this one. If you are not getting that, definitely that is not going to called as a factor of the polynomial. I hope you understood it nicely. Watch the next part.